Hello everyone. In today's video, we are going to discuss about solar space cooling of buildings. Introduction. This presentation will introduce the concept of solar-powered space cooling as a sustainable solution for building design. We will explore the benefits of this technology and its impact on energy efficiency. Energy efficiency and sustainability. Energy efficiency is a key factor in sustainable building design. Solar powered space cooling systems can significantly reduce energy consumption and lower greenhouse gas emissions. By harnessing the power of the sun, we can create a more sustainable future for ourselves and the planet. Solar powered space cooling. Solar powered space cooling systems use photovoltaic panels to generate electricity from sunlight. This electricity is used to power the cooling system, which uses absorption refrigeration technology to cool the air. The result is a cost effective, energy efficient, and sustainable way to cool buildings. Solar space cooling of buildings using vapor absorption air cooling. The system consists of two parts, the solar collector and storage, and the absorption air conditioner and the auxiliary heating. The essential components of the cooler are generator, condenser, evaporator, absorber, and heat exchanger. This is the block diagram of the solar space cooling system. Working principle. The operation of air conditioners with energy from flat plate collector and storage systems is the most common approach to the solar cooling today. In essence, cooling is accomplished as the generator of the absorption cooler is supplied with heat by a fluid pumped from the collector storage system or from auxiliary. Heat is supplied to a solution of refrigerant in absorbent in the generator where refrigerant is distilled out of the absorbent fluid. The refrigerant is condensed and goes through a pressure reducing valve to the evaporator where it operates and cools air or water for the cooling space. The refrigerant vapor goes to the absorber where it comes in contact with the solution which is weak in refrigerant and flows from the generator. The vapor is absorbed in the solution which is then returned to the generator. A heat exchanger is used for sensible heat recovery and greatly improves cooler COP. For solar operation, there are two additional factors: the temperature required in the solar collector to drive the process and the ratio of cooling produced to solar energy incident on the collector. Pumping to more absorbent solution may be by mechanical means or by vapor lift pumping in the generator. For low pressure systems like lithium bromide water system requires water cooling of absorber and the condenser. The coolers used in most experiments to date are lithium bromide and water machines, water cooled absorber and condenser. The pressure in the condenser and generator is fixed largely by temperature drops across heat transfer surfaces in the generator and condenser. The pressure in the evaporator and absorber is fixed by the temperature of the cooling fluid to the absorber and by the temperature drop across the heat transfer surfaces in the evaporator and the absorber. Thus, to keep the generator temperatures within the limits imposed by the characteristics of a flat plate collector, the critical design factors and operational parameters include effectiveness of the heat exchangers and coolant temperature. Common practice in solar experiments has been to use water-cooled absorbers and condensers, which in turn requires a cooling tower. This is a basic implementation of the solar cooling. Benefits of solar powered space cooling. Solar powered space cooling offers numerous benefits, including lower energy bills, reduced environmental impact, and improved indoor air quality. It also helps to reduce our reliance on fossil fuels and promotes the use of renewable energy. With solar powered space cooling, we can create a more sustainable and comfortable living environment. Applications of solar powered space cooling. Solar powered space cooling systems can be used in a variety of applications, including residential, commercial, and industrial buildings. They are particularly useful in hot and sunny climates where traditional cooling systems are inefficient and expensive. Solar powered space cooling can also be integrated into existing buildings, making it a versatile and attractive option for sustainable building design. In conclusion, solar powered space cooling is a sustainable and cost effective solution for building design. By harnessing the power of the sun, we can reduce our reliance on fossil fuels and create a more sustainable future. Let's work together to promote the use of renewable energy and build a greener world for generations to come. Thank you.